Hello everyone, welcome back to class 6 series on my channel Mathify with Minakshi. In our previous videos, we explored common factors, common multiples, prime numbers and composite numbers. Now let's take one step forward and in today's video, we are going to learn about prime factorization and divisibility test, the two very important concepts of this chapter. So let's start with prime factorization. Now, what is prime factorization? Prime factorization is finding which prime numbers multiply together to make it the original number. Here, the original number is always a composite number. What is composite number? A number that have more than two factors. So I can also say that prime factorization is the process of writing a composite number as the product of prime numbers. And what is prime number? A prime number can only be divided by 1 or the number itself, so it cannot be factored further. I will give you one example. Like suppose you have to find the prime factorization of 210. What you will do? First, you will think that by which prime number you can divide 210. As the last digit is even, so you can divide it by 2. And when we have to divide it by 2, that means you have to simply write half of this number. That's 105. Now, because the last digit is 5 now, so we can't divide it further by 2. So you can divide it by 3? Yes, because the sum of digits is 6 and 6 is divisible by 3. So we can divide this number by 3. 3 into 3 is 9, 1 left, so 3 into 5 is 15. Now the last digit is 5, so you can also divide by 5. 5 into 7 is 35 and then 7 into 1 is 7. So I can write that prime factorization of 210 is 2 into 3 into 5 into 7. So now let's move to figure it out. That's based on this concept prime factorization. So this figure it out is on page number 120 of your textbook Ganita Prakash. Question number 1. You have to find the prime factorization of the following numbers. So I will do prime factorization of some numbers for you and rest you can try on your own. So I will not do 64, that's very easy. So I will start from 104. Again, the last digit is even, so you will start with 2. And whenever you will divide by 2, just think that you have to take half of 104, that's 52. Again, the last digit is even, so I can divide by 2. Again, just take the half, 26. Again, the last digit is even, so I can divide by 2. Half is 13. And you know that 13 is prime, so you can divide that only by 13. So this is the prime factorization of 104. I can write that 104 is 2 into 2 into 2 into 13. Now we'll do for 105. Now what is 105? Again, the last digit is odd here, so we can't divide by 2, but the sum of digits is 6, so we can divide by 3. 3 into 3 is 9, 1 left, that's 15, so 3 into 5. Now again we can divide that by 5, so 5 into 7 and then 7 into 1. So we can write that 105 is 3 into 5 into 7. So what is your homework? I will encircle that number. 64 is your homework. Now we'll take the prime factorization of 243. Again, the sum of digits is 9, so we can divide by 3. 3 into 8 is 24 and 3 into 1 is 3. Again, we can divide by 3, that is 27. Again, we can divide by 3, that is 9. Again, we can divide by 3, that is 3. And again, we can divide by 3. So 243 means that for 243, we can say that 3 is coming 6 times, or you can say 3 raised to the power 6. Now for 320, that's your homework. Now we'll go for 141. Again, the sum of digit is 6, so we can divide by 3. 3 into 4 is 12. 2 left, that's 21 is 7. And you know that 47 is a prime number. So you will write directly 47. So that means 141 is 3 into 47. Now we'll do 1728. Again, the last digit is even. Whenever the last digit is even, you will divide by 2. And when we divide by 2, that means you have to simply take half of it. So 8, 6, 4. Now again we can divide by 2. So take half of this. 4, 3, 2. Again we can divide by 2. So 2, 1, 6. Again we can divide by 2. So 1, 0. 8. Again we can divide by 2, that's 54. Again we can divide by 2, that's 27. Now 3 into 9, then 3 into 3, and then 3 into 1. So what is the prime factorization of 1728? I will write that for you. 2 is coming how many times? Just count 1, 2, 3, 4, 5, 6. So 2 is coming 6 times, and then 3 is coming 3 times. This is the prime factorization of 1728. Now we'll go for 729. Again, if you will add, you will get 18. So we can divide by 3. So 3 2s are 6, then 1 left, 12, that's 4, and then 3. 3 into 81 is 243, then 3 into 27 is 81, then 3 into 9 is 27, then 3 into 3 is 9, then 3 into 1 is 3. So we'll write the prime factorization of 729 is 3 is coming 6 times. Then we'll do for 1024, although you should know that 1024 is 2 raised to the power 10. So 2 will come 10 times. Half, you have to simply take the half when the last digit is even. So we'll divide by 2. Then 256. Then again half, that's 128. Then again half, that's 64. Then again half, 32. Then again half, 16. Again half, 8. Again half, 4. Again half, 2. And then last 1. So you can write that 1024 is 2 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we'll write 1331. 1331. You should know that 1331 is 11 into 11 into 11. If you don't know, then you should know the divisibility rule of 11. That's if you will add the alternate numbers like 1 plus 3 and 1 plus 3. So the difference of sum of alternate numbers should be either 0 or multiple of 11. So it's 0, that means it is divisible by 11, that's 121. And then 121 is again divisible by 11, 11 into 11, and then again 11 ones are. So you can write that 1331 is 11 into 11 into 11. And last, that's 1000. Here I want to tell you one thing, that whenever a number is 10, so prime factorization is 2 into 5. Whenever the number is 100, so prime factorization is 2 2s and 2 5s. Whenever the number is 1000, so prime factorization is 3 2s and 3 5s. That means that for 10 we are writing 2 into 5. For 20 we are writing 2 2 times and 2 5 times. So for 30 we'll write 3 2 times and 3 5 times. That you should know. So we know the prime factorization, that 3 times I will write 2 and 3 times I will write 5. So let's divide 3 times with 2. So it's 500, then again half 250, and then again half 125. Now we have to divide by 5. So that's 25, then 5 into 5 is again 25, and 5 ones are 5. So you can write that 1000 is equal to 3 times 2 and 3 times 5. Yes, now let's move to question number 2. So here I gave you two parts as homework, 64 and 320. Now let's move to question number 2. The prime factorization of a number has 1, 2, 2 threes and 111. So they are saying just tell the number. They have already told you the prime factorization. So we have to simply multiply the numbers. That is 2 into 3, that is 6 into 3, 18 into 11. And you should know the trick to multiply any number with 11. What we can do? Just write the numbers at corner 1 and 8 and then sum. That's 9 in between. So answer is 198. This middle one is sum. Okay, now let's move to question number 3. Question number 3, find three prime numbers all less than 30 whose product is 1955. So whenever they will give you product and they will say write the prime numbers whose product is 1955, that means indirectly they are just asking the prime factorization of 1955. So as the last digit is 5, so you know that it is always divisible by 5. 5 into 3, that's 15. 4 left, 45, that's 9, and then 1. Now 391. You know that 391 is not divisible by 3, 5, not 7. So can we say that it is divisible by 11, 13, or 17, you have to think. But yes, if you know that it is divisible by 17, because 17 into 2 is 34, and then 5 left, that is 51, and that's 3, and then 23 is a prime number, so you can write simply 1. So we know that 1955 is a product of three prime numbers, that is 5, 17, and 23. Yes. Now let's move to next question. Find the prime factorization of these numbers without multiplying first. That means you have to do the prime factorization first separately, and then you will attach their answer. So I will do the prime factorization separately. For 56, as the last digit is even, so we'll divide by 2. Dividing by 2 means you have to simply take its half, 28. Then again you will divide by 2. Then again you will divide by 2. Then 7 is a prime number, so you will write 7 into 1 is 7. Here 25 is 5 into 5, and then 5 into 1. So I can write at last that 56 into 25 is, just attach their prime factorization. First you will write the prime factorization of 56, and you will write multiply sign and then attach the prime factorization of 25. So this is your final answer. Now again we'll do the prime factorization of 108 and 75 separately. So for 108, as the last digit is even, so we'll divide by 2, that is 54. Again the last is even, so we'll divide by 2, that's 27. And now we can divide by 3. 3 into 9 is 27, then 3 into 3 is 9, and then 3 into 1 is 3. Now you will do the prime factorization of 75. You can do by 3. 3 into 25 is 75, then 5 into 5, and then 5 into 1. And again you will attach the prime factorization. So you can write 108 into 75 is 2 into 2 into 3 into 3 into 3, and then write the prime factorization of 75. So this is your final answer. Now we'll do this last part, that's C part. So again you will do the prime factorization of 1000, that we have already done in first part, and same for 81. So let's do that fast. We'll divide by 2, again we'll divide by 2, and again we'll divide by 2, because the last digit was even. But now the last digit is 5, so you can divide by 5. 5 into 25, 5 into 5, and 5 into 1. Here 81 we can divide by 3, because the sum is 9, that is divisible by 3. 3 into 27, 3 into 9, 3 into 3, and 3 into 1. So for final answer you will write 1000 into 81 is equal to, first you will write the prime factorization of 1000. Then you will write a multiply sign and attach the prime factorization of second number. So this is your final answer. Now let's move to fifth question. What is the smallest number whose prime factorization has three different prime numbers? So it's very easy. You have to write number is equal to, now you know that three different prime numbers, but you have to write the smallest number. So you will write smallest three different prime numbers, that is 2 into 3 into 5. So that's 2 into 5 is 10. So 3 into 10, 30. And now you have to write with four different prime numbers. So again you will write that number is equal to, now you will write four different prime numbers, 2 into 3 into 5 into 7. Till here we have already solved, that's 30. So 30 into 7 is 210. So that's it, because I told you that you have to write smallest number. That's why you are taking smallest prime numbers. Now let's move to next figure it out. That's on page number 122. Question number 1. Are the following pairs of numbers co-prime? Guess first and then use prime factorization to verify your answer. First they are saying that you have to guess. Just see the last digit 0 here and the last is 5 here. So we know that both the numbers are divisible by 5. So they are not co-prime. Here it's 57 and 85. So you know that 57, 5 plus 7 is 12. It is divisible by 3. But here it is not divisible by 3. Here it is 85 is divisible by 5. But 57 is not divisible by 5. So that means it seems to be co-prime. Let's move to C part. 121 and 1331. That we know both are divisible by 11. So they are not co-prime. 343 is 7 cube. 7 into 7 into 7, and 216 is 6 into 6 into 6. So that means there's no common factor. So again they are co-prime. So that was our guesswork, but we have to do prime factorization to verify your answer. So let's do prime factorization of both the numbers. Prime factorization of 30 is 2 into 15, then 3 into 5, and then 5 into 1. And for 45, you can write 3 into 15, then 3 into 5, and 5 into 1. So for co-primes, you have to just see that we have any common factor or not. So you will write the prime factorization first. And then you realize as the common factors are 3 and 5, that means you can say that your HCF is 15. That is not equal to 1. HCF should be 1 for co-prime. That means the numbers are not co-prime because they have common factor other than 1. Let's move to next part, 57 and 85. As we know that 5 plus 7 is 12, so it's divisible by 3. 3 into 1 is 3, then 27, that's 19. 19 is a prime number, so 19 into 1. Then we'll do for 85. As the last digit is 5, so we can divide by 5. 5 into 1 is 5, then 35 left, that's 7. And again, 17 is a prime number, so 17 into 1. We can write 57 is 3 into 19, and 85 is 5 into 17. As HCF is 1, because there is no common factor, this implies the numbers are co-prime. Let's move to C part, 121 and 1331. We know 121 is 11 into 11 and 11 is a prime number, so 11 into 1. For 1331, you should know it's divisible by 11. If you will take the sum of alternate numbers and then you will take the difference, it's 0. So that means it is divisible by 11. So you will write that it is 11 into 121, and then 121 is 11 square, that's 11 into 11, and then 11 into 1. So we can write that 121 is 11 into 11 and 1331 is 11 into 11 into 11. So we can say that HCF is here 11 into 11, that's 121. So not co-prime. Then we'll do for 343 and 216. 343 is 7 cubes. You can write 7 into 49, then 7 into 7, and then 7 into 1. For 216, as the last is even, you can divide by 2. It's 108, then 54, then 27, and then we can divide by 3. 3 into 9, 3 into 3, and 3 into 1. Then you can write as 343 is 7 into 7 into 7, and 216 is 2 into 2 into 2 into 3 into 3 into 3. Again, the SCF is 1, so you can say the numbers are co-prime. Now, let's move to question number 2. Is the first number divisible by the second? Use prime factorization. So using prime factorization, you have to check that first number is divisible by second or not. So I will take prime factorization of both the numbers separately, like we did in question number 1. So we can divide 225 by 3 as sum of digits is 9. So that is into 75. Then we can again divide by 3. That's 3 into 25 is 75. Then we can divide by 5. 5 into 5 is 25, and then 5 into 1 is 5. Now 27 we can divide by 3. 3 into 9, then again 3 into 3, and then 3 into 1. So as you can see here that 27 prime factorization, that is 3 threes, is prime factorization of 27 is contained in 225. You will write no, as prime factorization of smaller number. So here smaller number is 27. Prime factorization of 27 is not contained. So this not is very important, as it's not contained in prime factorization of bigger number, that's 225. This implies that 225 is not divisible by 27. If prime factorization of 27 was contained in prime factorization of 225, then you will say yes, it is divisible. So let's move to second part now. 96 and 24. We'll take the prime factorization. You can't write directly that yes, 96 is divisible by 24, because we know that 24 into 4 is 96. Because they wrote that you have to use prime factorization. So we'll do prime factorization first. We'll divide by 2. So it's 48. Then again we'll divide by 2, it's 24. Again we'll divide by 2, it's 12. Again we'll divide by 2, it's 6. Again we'll divide by 2, it's 3. And then 3 into 1 is 3. For 24, again we'll divide by 2, that's 12. Then we'll divide by 2 is 6. Then 2 into 3, then 3 into 1. So this time triple 2 and 1 3 is contained here. Triple 2 and 1 3. So we can say as prime factorization of 24 is contained in prime factorization of 96. So we can say here as prime factorization of 24 is contained in prime factorization of 96. This implies that 96 is divisible by 24. Let's move to next part. 343 and 17. We know that 343 is 7 into 7 into 7. That means 7 into 49, then 7 into 7, and then 7 into 1. But 17 is a prime number, so just write 17 into 1. Again, you know that 17 is not contained in the prime factorization of 343, so that is not divisible. So you will write as prime factorization of 17 is not contained in prime factorization of 343. This implies that 343 is not divisible by 17. Let's move to last question, triple line and double line. We can simply divide by 3, 3, 3, 3. Then again we can divide by 3, 1, 1, 1. Then again we can divide by 3. And 37 is a prime number, so just write 37. For 99, you will write 3 into 33, then 3 into 11, and then 11 into 1. Now, we have to check 2, 3 and 111 is contained here. 2, 3 are there but not 111. That's why you will write as prime factorization of 99 is not contained in prime factorization of 999. This implies that 999 is not divisible by 99. Now, let's move to next question. Question number 3. The first number has prime factorization 2 into 3 into 7 and the second number has prime factorization 3 into 7 into 11. So this time they directly gave you the prime factorization and they are saying that are they co-prime? So first number is 2 into 3 into 7 and second number is 3 into 7 into 11. So are they co-prime? As you can see here that 3 is common, 7 is common. That means their HCF is 3 into 7, 21. That is not equal to 1. So they are not co-prime because for co-prime we need HCF as 1. So they are not co-prime. Now they're saying, does one of them divide the other? So you know this thing. For that, prime factorization of one number should contain in prime factorization of another number. But here, 2 into 3 into 7 is not contained in 3 into 7 into 11. So that's why you will write, no, they don't divide each other because the prime factorization of 2 into 3 into 7 is not contained in prime factorization of 3 into 7 into 11. So you can write that. I'm just writing no, they don't divide each other. Let's move to question number 4. That's the last question of this to figure it out. Guna says any two prime numbers are co-prime. Is it true? Yes. Yes, Guna is right. As any two prime numbers have only one as common factor. One is common factor, that is HCF is 1. This implies that two prime numbers are co-prime. But I want to tell you one note here, but the converse it's not true. That we can't say that two co-prime numbers are always prime. Two co-prime numbers are not always two prime numbers. Example, we can say that co-prime numbers are 4 and 5, but both are not prime. Or you can say 4 and 9. So we have a situation where both the numbers are not prime, but still they are co-prime. So that you should know. So that I have written as note. Now let's move to next topic. Now next figure it out is based on divisibility rule. So I have attached one pic for you. Just for a quick revision of divisibility rules, because you're already familiar with these rules, when the last digit is even, like 0, 2, 4, 6, 8, you can say that it is divisible by 2. When the sum of digits is divisible by 3, you can say the number is divisible by 3. When the last two digits of the number are divisible by 4, you can say number is divisible by 4. When the last digit is 0 or 5, you can say number is divisible by 5. When the number is divisible by both 2 and 3, you can say it is divisible by 6. When last three digits are divisible by 8, you can say the whole number is divisible by 8. When sum of digits is divisible by 9, you can say the whole number is divisible by 9. And when the last digit is 0, you can say that the number is divisible by 10. For 7 and 11, what you have to do, just learn this, although it's not in your syllabus, but you should know, that's for extra knowledge, that if you will double the last digit and subtract it from the remaining number, and if you will get the answer as 0 or multiple of 7, then your number is divisible by 7. And when you will take the difference of alternate numbers, that the odd position, and when you will take the difference of sum of digits at odd place and sum of digits at even place, and the difference is 0 or multiple of 11, then it is divisible by 11. But 7 and 11 is not for testing according to NCRT. But I have attached the rules because it will help you for taking the prime factorization. Now let's read question number 1. 2024 is a leap year, as February has 29 days. Leap year occur in the years that are multiples of 4, except for those years that are evenly divisible by 100 but not 400. You know this thing, that if you will check the last two digits and they are divisible by 4, then you can say that that's a leap year. But what if last two digits is 0? In that case, you have to check the remaining number. If the remaining number is divisible by 4, then it is a leap year. Otherwise, it's not a leap year. I will give you one example. Suppose 1600. That's a leap year because 16 is divisible by 4. But if you will take 1700 or 1800 or 1900, they are not a leap year because here 17, 18 and 19 are not divisible by 4. Now, first part is from the year you were born. So I'm assuming that as you are in 6th class, so your birth year will be 2015. Till now, that means 2026. So you have to write all the leap years from 2015 to 2026. So leap years are 2016, 2020 and 2024. So three leap years are there. And B part, from the year 2024 till 2099. How many leap years are there? So you will write leap years from 2024 till 2099 are. So I will write all the leap years. So you will write 2024 too, because they are from. In from we have to include these years too. Then second is 2028, then 2032, then 2036, then 2040, then 2044, then 2048, 2052, 2056, 2060, 2064, 2068, 2072, 2076, 2080, 2084, 2088, 2092 and 2096. So total there are 19 leap years from 2024 till 2099. Now let's move to question number 2. Find the largest and the smallest four-digit number that are divisible by 4 and they are palindromes. What are palindromes? That if you will read from right to left or from left to right, you will get the same number. I will give you an example like 1001. If you will read from here 1001 and if you will read from here 1001. 1. So that is palindrome. So you have to write largest and smallest 4-digit number, but the condition is it should be palindrome and it should be divisible by 4. So let's start. First, you should know that if the number is divisible by 4, then the last two digits should be divisible by 4. But they are saying largest number and it should be the palindrome. So this digit you should need highest, because then only you will copy the same digit here. So first I will write all the possibilities and I will start from last, like 96. If I will write 96, then the palindrome will be this 6996. Other combination can be 92, but if it's 92 and then palindrome will be, you will copy like this to make it palindrome. If it is next, it is divisible by 4, so you can write 88. Then to make it palindrome, again you will write 88. Then if you will write next number that is divisible by 4, that can be 84. And then to make it palindrome, you will write like this 4884. So you will realize that this number is the largest number that is divisible by 4 and it's a palindrome. Now let's write smallest. For smallest, again we'll try that the last two digits that are divisible by 4 should be smallest one, so that palindrome will also become smallest. So for this smallest divisible by 4, I will start from 04. That can be the smallest one. But again, to make it palindrome, you will write this. Then after 4, I can write 08. Then to make it palindrome, I have to write like this. Then after that, I can write 12. Then to make it a palindrome, you will copy like this, 2112. Then I can write 16. And then to make it a palindrome, you will write like this. So the smallest one, when you will write all the combination, is this one. So this is the smallest number divisible by 4 and it's a palindrome. So I have explained you that how you will do hit and trial to get this answer. You will always start from last two digits because you have to fulfill the condition that it should divisible by 4. Now let's move to question number 3. Explore and find out if each statement is always true, sometimes true, or never true. You can give examples to support your reasoning. A part. Sum of two even numbers gives a multiple of 4. We can't say it's always true. We can't say it's never true. So we have to write sometimes true. When we are writing sometimes true, that means sometimes it is true, but sometimes it is false. So you have to give example for both the cases. When it is true and when it is false. So they're saying take two even numbers and sum is a multiple of 4. So first we'll give the example of true. That means we'll take two even numbers and the sum should be multiple of 4. So I can write 2 and 6. So 8 is a multiple of 4 and both the numbers are even. Next we have to give the example of false. So I can write 2 plus 4, as again both the numbers are even, but the sum, that is 6, is not a multiple of 4. Now let's move to B part. Sum of two odd numbers gives a multiple of 4. Again, we can't say it's always true. We can't say it's never true. So answer is sometimes true. Again, to support your reasoning, you will give one example for true and one example for false. For true, you have to write two odd numbers whose sum is a multiple of 4. So I can write 1 plus 3. Again, both are odd and sum is multiple of 4. And for false, you can write 1 plus 5. Again, both are odd, but sum is 6. That is not a multiple of 4. Now, let's move to question number 4. Find the remainders obtained when each of the following numbers are divided by 10, 5, and 2. Normally, what you can do, like these are the numbers 78, 99, 173. So, one way is that you will normally divide the numbers by 10, 5, and 2 and check the remainder. But now we are in 6th class, so we can simply follow one thing. So, I've written with blue. That's a rule here that you know that if we want to divide a number by 10, then the remainder is always the last digit. And if we want to divide any number by 5, then the remainder depends on these condition. If the last digit is less than 5, then remainder is directly the last digit. If the last digit is 5 or 0, that means that the number is divisible by 5. So remainder is 0. And if the last digit is more than 5, then remainder is last digit of the number minus 5. And when you will divide by 2, then if the last digit is odd, then your remainder is 1. And if the last digit is even, then remainder is 0. So first we'll see for remainder when divided by 10. Here you have to simply copy the last digit, that is 8, 9, 3, 2, 0, 1 and 5. Now we'll see for 2 because that is also easy. You have to just check the number is even or odd. Because the number is even, so remainder is 0. Number is odd, remainder is 1. Again the number is odd, remainder is 1. Again the number is even, so remainder is 0. Again the number is even, so remainder is 0. Again the number is odd, so remainder is 1. Again the number is odd, so remainder is 1. Now, for 5, you have to check if the last digit is 0 and 5, then the remainder is directly 0. And if the last digit is less than 5, like here 3, 2, and 1. For less than 5, you have to copy the digit as it is. And when the last digit is more than 5, in that case, you have to simply subtract 5 from that number. So in this case, your remainder is 8 minus 5, that is 3. And here remainder is 9 minus 5, that is 4. So we are done with this question. Now let's move to next question. Question number 5. The teacher asked that if 14560 is divisible by all 2, 4, 5, 8 and 10, Guna checked for divisibility of 14560 by only two of these numbers and then declare that it is also divisible by all of them. What could be those numbers be? Now you should know one thing, that if a number is divisible by any number, then it is also divisible by its factor. Example, if a number is divisible by 6, then it means that it is also divisible by 2 and 3. So Guna used this fact only. He knows that if a number is divisible by 8, then automatically it is also divisible by 4 and 2. And if a number is divisible by 10, then automatically it is also divisible by 2 and 5. So this implies that Guna will check divisibility of 14560 by just 8 and 10, because automatically if it is divisible by 8 and 10, it is divisible by 2, 4 and 5 too. So let's move to question number 6. Which of the following numbers are divisible by all 2, 4, 5, 8 and 10? And the numbers are 572, 2352, 5600, 6000 and 77622 160. As we just discussed that if a number is divisible by 8 and 10, then automatically it is divisible by 2, 4 and 5. So we have to just check for 8 and 10. So I will write that for you. Numbers that are divisible by all 2, 4, 5, 8 and 10 are those numbers that are divisible by 4 and 8. Are those numbers that are divisible by 8 and 10. But as you can see here that 572 and 2352 are not divisible by 10 because the last digit is not 0. Are not divisible by 10 as last digit is not equal to 0, because for divisibility of 10 we need last digit as 0. So no need to check 572 and 2352 for any number because it is not divisible by 2. Now we have to just check numbers 5600, 6000 and 77622 160. So we have to check the divisibility by 8 and 10. We know that for divisibility of 8 we have to just check the last three digits. If last three digits are divisible by 8, you can say number is divisible by 8. And if you will see them carefully, yes, all three That means last three digits of all three are divisible by 8. And that means these numbers are divisible by 8. Now we have to check for 10 too. So for 10, we just need last digit. And as you can see here, the last digit is 0 here. So it is also divisible by 10. This implies that these numbers are divisible by 10. So in short, we can say that these three numbers 5600, 6000 and 77622 are divisible by all of 2, 4, 5, 8 and 10. Now let's move to last question of this chapter. Write two numbers whose product is 10,000 and the two numbers should not have 0 as the unit digits. So first we'll take the prime factorization of this number. As you know that the last digit is even, so we'll divide by 2. That means we have to simply take its half, 5,000. Again the last digit is even, so we'll divide by 2. That means again we'll take half. Again the last is even, so we'll divide by 2. Again the last is even, so we'll divide by 2. Now we know that the last digit is 5, so we can divide by 5. Again the last is 5, so we can divide by 5. Again the last is 5, so we can divide by 5. And now 5 is a prime number, so just write 5 into 1 is 5. Now here you have to be careful that 10,000 can be written as 4 times 2 and 4 times 5. Now you have to select any two prime numbers whose product is 10,000. But you know that there it's given that 0 should not be the unit digit of any number. And when the 0 will come as unit digit when you will attach 2 and 5. So what you have to do here, you have to separate these 2's and 5's. So you will say that your first number is all 2's together, that is 2 into 2 into 2 into 2, that's 16. And your second number is all 5 together, that is 5 into 5 into 5 into 5, that's 625. So this is your answer, that this is your first number and this is your second number. So we have covered this chapter, prime time. If you found this video helpful, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Thank you everyone.